Welcome to this CreatorConf 2017 video. A big thank you to all the speakers that took time to give these talks. Hopefully you enjoy this video series. And also be on the lookout. You can go to creator.io to get all the latest JavaScript news. And you can also follow me on Twitter at Josh Owens. And we've got some other exciting stuff coming up in 2017. Thanks. Enjoy the video. We have an amazing speaker, Todd Motto, with us. Welcome, Todd.
Hello. How are you?
He's going to be talking about Angular and specifically Angular 2. And I know, like, I've followed your stuff, Todd. Do you still work for? Gosh, I'm drawing a blank now.
I'll see how long you can go without remembering it. Telerik, do you mean?
Telerik, yes, yeah. Well, they got bought. I was trying to think of the company that bought Telerik.
Oh, Progress.
Yeah, Progress. That's it.
Yeah, that's the one.
Yeah. So, and you're kind of a dev evangelist for NativeScript, right?
It was. I actually left in December. I'm basically train people on Angular full time now, so that's my jump into the wind, is to go full time for myself. So yeah, I basically do Angular training full time for myself. So yeah, I was working with those guys. Sadly, had to kind of follow my dream a little bit. So
yeah.
So yeah.
Understandable. All right. Well, I will let you take it away. And if anyone is interested, Todd just mentioned he's doing training, so be sure to follow him on Twitter and check out the stuff he's offering. He has some great classes. So
Thank you. Yeah, I'm going to share my screen. I should do the trick. And then I'm going to stop my video because my bandwidth is not the best. Can you see that okay? Is that ready to roll?
Yeah, you're good. We can see it.
Cool. I can just see my full screen, so I'd like to double check before I go on a rant for half an hour. Cool. So this is kind of a primer talk on thinking in component architecture. And it doesn't necessarily have to be specific to Angular itself. This can be applied to things like React, where React made this component architecture and unidirectional data flow much more popular. So we're going to look at the concepts of component architecture and then how we can essentially apply that to Angular. It's kind of been renamed from, well, not renamed, it was always Angular, but it's been known as Angular 2 for a few years now, but it's basically just been called Angular. So if you hear anyone talking about Angular instead of Angular 2, that's what it means. And then anything Angular 1, we just call angular.js now. So this is why I've removed the 2 from the end of my talk and some other places. So if you wanted to ask any questions, I'll bump some of these up best I can. You can follow me on Twitter and ask some questions that might come to your mind at some point during the next week, maybe. So I just mentioned to Josh that I run a training company called Ultimate Angular, which we basically specialize in building courses from zero to hero, we'll call it, on anything Angular 1, Angular 2, and we also do TypeScript. So that we've got like a whole ecosystem covered on ultimateangular.com if you want to go and check that out. So I've kind of mentioned what the talk's going to be about. So it's going to be about component architecture. Then we're also going to look at what I call the different, well, many people call it the different types of components, but we'll call it this as well. So we're going to investigate the different types of components that we can create. Then we'll look at the concept of one-way data flow as well. And then we're going to look at how we apply that to Angular. So what is Angular for those who have maybe used Angular 1 or are new to Angular 2 and above? So it's the successor to Angular 1, now known as Angular, just Angular.js. It's pretty cutting edge. It doesn't work in some of the sort of older browsers like IE8, for example. So it's focused on the next 5 years and beyond. So it's very cutting edge framework, and some of the APIs that it uses are just being added to browsers now, such as like web worker support. You can bootstrap Angular in a web worker, for example. So this gives you a platform to basically build with from now to the next 5 years. So it's good for evergreen browsers, we'll put it that way. It sits on top of the web platform. This was a really nice feature. I was just doing some recording this afternoon, which uses native Shadow DOM with Angular. So this is a really powerful feature for things like style encapsulation. So we're not sort of emulating this stuff. It uses a component-based architecture. So we're not just sort of creating the MVC model, typical sort of huge page with loads of bindings, for example. And the cool things are that it can be deployed to both web, the mobile web, with something like Ionic. And we also have NativeScript, where I used to work for Telerik. They used to build, well, they still build NativeScript, not used to, which you can essentially, NativeScript would take your Angular code and compile it down to a native mobile code. So you're in fact transforming perhaps a desktop, perhaps a web application down into mobile. So you can basically share the same code base, which is what Angular is good for, is sharing that on multiple environments. You also got things like desktop with Electron, which you can deploy Angular to. So we'll start with component architecture. I like to use this, hopefully everyone can see the screen as it is on mine. Some projectors and stuff at conferences like to cut off bits. So this is how I kind of go about trying to drill people's minds into component architecture, is just say, we got 4 boxes here. One of them's a search box, one of them's a list. So you can imagine this is like your Gmail, where you've got the search for a message at the top. You've got your list like inbox and draft and trash messages on the left. And then you've got the chat that you can put on the right or below the list, but we're just keeping it simple here. And then the view container is what we call like a component root, or some kind of container that changes different components based on the router. So if you're at /inbox, you're probably going to see a list of your emails. If you click on an email, this view container will then bring in the component to be able to display that particular email, which then go and fetches the data, etc. So these are just like building block ideas for starting to think about components one by one. So for the duration of this talk, we'll look at a completely made up chat component. So inside the chat component, if you imagine you were to start thinking about the features that you were going to build, you would have like a chat profile. So if you go into like Google Hangouts, for example, or any other chat client, you can usually see the person's profile. You can see whether they're online or offline or away, for example. And then you also have like the chat list. So in Hangouts specifically, you also get the list of friends that you can chat to, and you can click on them and you can go and type a message, for example. And finally, we have a chat search. So I'm going to say we're going to have the feature to be able to search the list of people, for example. So let's assume I have 500 contacts. I could just type somebody's name into the search, and it will like fuzzy search their results. Now, the easy part is defining. Now that we've defined like the features, is how do we break these down into thinking about components and component architecture? So the idea is that everything's pretty much a component, but then we're going to work out how to think of the different types of components to build this feature without kind of making a mess and keeping things clean and easy for us. Now, if you've used custom elements, part of the web component spec, or you've used Angular, which allows you to use custom elements, or something like React, which also uses JSX, where you could create something like a chat component which uses JSX. In Angular, we use native components, so we can just create a custom element called chat. The way that we can then display the children, this just uses some simple naming terms such as chat profile, the chat list, and the chat search. So the idea here is we've got this container called chat, and it then renders or does something with these 3 child components. This is the DOM tree of how to think of it. So you've got these 3 child components of this one bigger component. So we're going to use these 3 or 4 components in this kind of story to kind of introduce the concepts and then how they apply to Angular. So we mentioned that we have like a parent component and then a few child components, but a component could be more defined than just being a boring component or it doesn't do anything itself. So the idea is that we have these different types of components, which are generally referred to as perhaps a stateless component or a stateful component. And you may have heard of these being called presentational and container components, or smart and dumb components. So the idea here is that you have two different types or slightly different types of components that have different rules or some kind of guidance that helps you build out your application using components. So I've got these basically look the same apart from the red box here. So this indicates that something else has happened. So we'll dive through these and understand what the differences are. Excuse me. So for a stateless component, what we like to do is imagine your component is some kind of API, maybe like a function callback or some kind of configuration that you want something to do. And when you create like a JavaScript function, you obviously pass some kind of function argument, and then you can use that argument inside the function. So the idea here is that a stateless component will receive some kind of arguments, which we call an input, and it will do something with those arguments. And when you're done, inside a JavaScript function, what you would do is typically return whatever you've done to the data, for example, that's come through the function argument. And the return statement is what we call an output. So I try and think of these as just pure JavaScript functions. We pass some data in, and then it does something, and it returns some new data, for example. So you can think about that as a component. You just apply the JavaScript function thinking to it. So the idea is that maybe I have a chat list where I want to render out these as a stateless component, and I pass the list into a component, and then I click on a person, and then I want to send a message to the parent to say I've just clicked on this person. So this is what we do. As you can see, point number 2 says the data enters via an input, which we call property binding in Angular, and the data leaves and the data is completely up to you what you want to like emit as an event output. Typically, if you're doing something like a click event, you could pass a unique ID that the person you've just clicked on, for example. And I've just mentioned that we can also call these stateless, dumb, or presentational. So this is kind of the idea that they don't have any, they are simply pass data and they can do something with data and they return new data. So you can see that it's not fetching data at this point itself. So this is where what we call a stateful component, so it actually contains the state or can go and fetch state, comes into play. So the idea is that this, well, in Angular, we have something called a service. So you can see on the top line, we have communicate with services. So the idea here is that we inject something called a service, which can go and fetch our data, and then we bring it back to the component. So that the service basically gives that component the piece of data, which is when we would like render out here. We got render child components. So at this point, we would pass the data down into these child components, such as our list. So the data is stored in this component, and we simply just pass a reference to it into the child components. So if I flick back to the stateless one, these are typically what are rendered by the stateful component, and we essentially pass it down. So that's kind of the thinking behind it. This also ties nicely with something called one-way data flow or unidirectional data flow. And I've got some diagrams again just to show the kind of relationship between services, components, and then we'll look at events and how they play into one-way data flow. So the idea, let's assume that we've just loaded our mail application. We want to obviously go and get that user's mail who's just logged in. So at this point, the service would make an XHR request. It would go and do all its credential checking stuff, come back true. So yes, the user is authenticated to go and fetch these messages. It would then bring back that response, and we can just simply bind it to the component. Now at this point, in the components template, we want to render these 3 child components below. So you can see here the 3 arrows are essentially just describing how the data is passed from the top to the next level down. And you can see the box on the right. So we use something called property binding because Angular uses the native JavaScript properties in the actual elements themselves. So if you've looked at the double curly braces in Angular where you interpolate a value, this is actually like sugar syntax. So let's assume you had a h1 tag which you put some curly braces inside of, and you put the word title, and then did hello world equals, well, title equals hello world somewhere in the JavaScript. What this is actually doing is something like, if you imagine plain JavaScript, you do element.innerHTML or element.textContent equals a string. So it's essentially doing this under the hood. And then we go to the next level down. So this is completely made up and completely optional depending on how many components you have. So the idea is that the top level container holds the data, gets passed down to this component. We can then pass it down to further components and further should you like. So that's typically like an initial render of some kind, or it might be a next render if you've just changed views perhaps. So let's assume that we're editing a form, for example, and we want to make a change to the stateless component that's deep buried down in the component tree. What we would do is essentially fire an event. So this ties in with the one-way data flow. The data flows down. When we want to make a change, we then capture that change and then pass it back up to the next level. And then we then go back up to the next level. If that component doesn't rely on the piece of data that's just been passed up, it can then pass it up again. And then it can tell this smart component at the top that something has actually happened. So let's assume that this component here, hopefully you can see my mouse kind of wiggling. So let's imagine we just click delete on somebody, and this arrow is representing their unique ID that's being passed up. We can then pass it up again to this parent component, the stateful component, which is smarter. It has a service bound to it. And the component can then go off to the service and say, please delete this particular user. So that's the idea of breaking things down into components, and each component has its own kind of rule set or rule that it abides by. And that's the final arrow, which passes it to the service. Hopefully that last bit made sense. So what we're going to look at now is how Angular basically applies all of these concepts. Hopefully this is good enough to view. However,
I can read it.
Yeah, perfect. So much like other frameworks or libraries such as React, you need a root component. So in Angular, we need to create an app component, which we generally do. I'm just going to skip down here. So you can see we have this selector. We have a selector called app. So this would basically live inside the index.html. So to actually create a component in Angular, you can see we have this import component. You can ignore the on and init piece for now. So this is called a decorator, which this is using TypeScript to demonstrate how we actually create a component. So the idea behind the decorator is that they hold specific metadata for this component class, which is underneath. So here we have a simple constructor. It says this.message equals hello world. So the idea here is that we take the message property on the class, and we can simply bind it using the at component. So this is a decorator. Decorators are likely coming to JavaScript soon. I think they're stage 2 at the moment. So they will hopefully be in the language, but they essentially allow us to annotate something like an ES6 class or a property and kind of add powers that we want. So you can have the ability to write your own decorators. These are custom decorators that Angular has written and relies on TypeScript to basically give you. So at compile time, Angular basically binds this component, it merges it with the at component decorator, and you can see we have message logged out here, and we have this.message. So it kind of joins the two. So that would give us like a hello world status. Now the on init piece is simply just a lifecycle hook. So if you've used like Angular 1.x or like React, I think some other frameworks have lifecycle hooks as well. But it's essentially key points in time of the component itself. So they're component specific, and they tell you different things about what's happening at a current time. So if we were passing data into a component, we could listen for those changes where new data comes down via an on changes. So these are different kind of well, we call them interfaces, which is why we use implements on init here, and then we have the ng on init here. So at this point in time, the component has been initialized by Angular. Now, this is where we essentially, inside the base component, we're going to talk through the chat component that we looked at the beginning to understand how we render it and then sort of let the data flow down a few components, and then we're going to make a change and then pass it back up. So inside the template for our app, we're simply going to have a main element, and inside of that, I've just got chat. So I'm just, like we looked at the beginning, we had the 3 columns, and we said it's just going to have a base element of chat, which essentially just encapsulates all of the behavior for like a chat module, or something that sits in the sidebar and allows us to chat to people. So this is kind of our first stateful or smart component or container component. And it would essentially allow us to go and fetch some data and then render that data down into other components. So for this piece, what we're going to do is just demo one of these components, but we're going to just import them and use them in the template to demonstrate how it kind of works based on the diagrams that we just looked at. So we have the chat profile that we looked at in the table at the beginning. We have the chat search and the chat list component. Now, Angular has something called a module, and we use an ng module, which we register these in. I'm not going to show that code because we're just concentrating on how to actually think about components. So inside of these, we have the chat profile, we have the chat search, and then the chat list. So this is just giving you an example with no logic at all. It's just purely thinking about component architecture and how we might structure our applications or break them down into smaller pieces. So at this point inside ng on init, I've put a comment here saying do stateful things. So at this point is where we can go off to the server, or we might have already got the data if you tie it in with something like a routing resolve, which basically preloads the data before you hit the component. But we're going to assume that we're just going to start off inside the on init. When the component is ready, we're going to go and fetch some data from our API. So all I'm doing here is basically hard coding the data. So we're going to assume that this is some kind of response that we've got back. We've got a chat user. So this is a public property under this. So this is part of the actual component class. It's just going to have my name and online is true. Then we're going to have a chat term. This could be like local state or initialized from the server. It depends if there's something you want to do with an initial value. And we also have chat friends. So if you log into Facebook, for example, it brings up all your friends in the chat bar. So this could represent your list of friends as an object, as a list of objects in an array. So if we take the chat user object, which we'll be focusing more on, let's go to our chat profile. So if we don't think about this too complex, we've got 3 components here. We've got the profile, we've got the search, and we've got the list. So on here, what we're basically doing is now providing some data to this chat profile. So this is taking a different approach to like Angular 1 and React and some other things. And you can see things like these square braces, which we'll come on to, of what they actually mean. But essentially, we just pass that chat user down as a value here. And you can see that's using the user property that I mentioned about how you use an h1 and perhaps the .init HTML, which is a native JavaScript property that it binds to. So Angular's square bracket notation essentially means that it's trying to bind to a property called user. So you could think about element.user, for example, if it supported that property. However, these are custom components, so we are responsible for creating the properties to allow Angular to bind to. We also have the chat term inside the smart component. We're just going to pass that down as a string. So we can say this is going to be an initial value for the search. Maybe you could cache it with local storage or something if somebody had half typed a name in and then refreshed the page or something like this. And then finally, the chat friends, which is our array of objects. We can then go up and just simply bind them using a property called friends. So hopefully that's kind of simple. We have 3 properties. We've got chat user, chat term, and chat friends that we then that exist in our component class, and we're now delegating them down into further components. And you can see here, like, I'm not attempting to create any click events or any of these things, because this is like a stateful/container component, which is responsible for just handling the data and side effects of data changes, and also rendering the child components. So the child components will be responsible for any changes that we make at this point. So now we've passed some data down, we obviously want the side effect side to happen. So back to our ng on init, we have the 3 objects that we just passed down. So let's assume that inside my chat user object, I have online as true. Now, if I change the online to false, perhaps in further down the component tree, I want some kind of notification in this component that the status has been changed. I don't really want to manage the status change 3 levels down in my component tree, because I want to manage it in one place and keep things nice and simple. Similarly, we have the search. So if I start typing somebody's name and I want to search for them and then click on their username if they are found, we can have some kind of callback when a search has been changed. Similarly, if I click on a contact that I found, or it just happens to be at the top of the search list, I can click on contact select. So these will expect some kind of event to be called back. At this point, we could then go off to the server and say, please initiate a chat or open a WebSocket with X contact, inside this callback here. So we'll start with on status change. How do we bind an event to this component? And you can see, like, I've not actually used any JavaScript as such. All I'm doing at the moment is thinking about how I'm going to think in components and how I'm going to pass pieces of information down and what I'm expecting to come back up. So I mentioned, think about the components as like an API. So if you want to create some components, you say, okay, what does this do? Much like when you create a function in JavaScript, you need to think what the function does. If it doesn't have a well-defined role, then it's probably not a good function. Whereas this component has a defined role. It accepts a user, and it can tell if the user has then gone offline via a status change. So the way that we do this is passing the function down as a value here. We expect this $event, so Angular will expose this for us. And you can see I've used a different type of syntax in the actual bindings here. So this will actually listen to events that are basically emitted from the component itself. Now, if I had a button and I did the bracket and then click, this will then listen for click events. So there's a difference in the syntax of the different types of bindings that we make, if that makes sense, hopefully. So when you're using a square brackets, you're essentially saying, I want to bind one way. So I'm binding downwards from the top into this component. Similarly, if you've just got an input and you want to bind an initial value, you would use square brackets value. So this is just binding a property, piece of data to a property. When it comes to events, so let's say you had a form or a click event of some kind, you would put the name of the event inside these braces here. So there's 2 different syntaxes for 2 different types of bindings that we want to make. It was kind of weird at first, getting used to this and trying to think like why to do this. But after you've used it for a few weeks, you kind of, the light bulb dings and it makes a lot of sense. And you can join a new development team and you don't have to kind of look through all the types of bindings and callbacks and stuff they've got. So using this syntax is quite explicit and easy. Similarly, with on search change, what we can do is just create a property called search change. We'll pass a function down as well. And then when a contact has been selected, you can probably guess we do the exact same thing. So by now my make-believe chat component and the subcomponents are populated, they're ready to go. So now we move on to a stateless component. So we're just going to be looking at one stateless component just to essentially see what it does, how it can be used. So I've imported a few things here. We've got on init, on changes, the input and the output, and the event emitter. So these all kind of sit hand in hand depending on what you want to do. Some components will just import component and input. If you need to go and tell the component that something's changed, you want what we call an output alongside the event emitter. So what I'll be doing for the next 5 minutes is kind of going, well, a few minutes is going back between these two, just so we can cross-reference and everything makes sense. So we looked at the slides at the beginning, and stateless components have like an input and they have an output. So the data is the input, and the new data that's changed is the output, which we would get back in here via $event. So we're saying here we have an input binding because we're using square brackets. We want to bind to something, and our input data is going to be the chat user. So the way that we do this is we import the decorator at input. Again, this does a lot of stuff under the hood for us to basically connect the properties. And we have this user property that we're saying is going to be an expected input, and all it's going to be is an object. Now, if you're using TypeScript, you'll probably want to create your own interfaces against your data structures and different objects and arrays, perhaps. However, we're just going to keep it simple with object. We also have an output. So if I flick back, we have the different binding, and then we have status change. So I am actually creating an output here called status change. Now, this is just a property on the ES6 or TypeScript class. So this is essentially this.user and this.status change, which you can see down here if you've been looking closely. So what we essentially do is create an instance of the new event emitter and bind it to the output. So this enables us to emit an event using the event emitter API and go and tell the parent. So we also have the ng on init. So what I'm doing here is basically just checking whether the user is online. So using the input decorator will allow us to basically bind to that user property and get the data associated with it. So inside of here, I'm just creating some real quick sort of local state that's just for display purposes. And we're going to say if this property is true, so the user.online, so we had online true, it could be false. If it's true, we're going to display the text online. If it's false, we're going to say offline. So this is just an example of using some local UI state here. And we also have the ng on changes. So ng on changes gives us this changes object. So if we, for example, because we're building single page applications, the state of the application is driven via JavaScript. So unless you're full page refreshing each time, you'll probably want to be using something like ng on changes to get a new piece of data if something changes. So let's assume that you maybe had your application on one computer and you went and logged in on another one and you changed your username. You could then maybe via a WebSocket have it hooked up, and then the data that's being passed down will have changed. So this changes.user here is basically seeing if the change has been affected to the user object, which we've bound up here. So if the change has been occurred, for example, that was kind of a bad example, but we do lots of state changes in our applications. Then what we basically do is merge the current value. This is completely optional, but it essentially breaks the bindings between the parent and the child component, because JavaScript objects and arrays are passed by reference. So here we basically break that. So we use the current value of the user and then just simply assign it to this.user. So we're kind of overriding it with new changes using a mutable operation, which is object assign here. So now that we've kind of looked at these, how do they affect the template? So here I've got welcome and then user.name. So that property at the beginning is going to hold my name. And then we've also got this local user status. So you can see it's not part of the user object that's being passed down. It's just some local state that just says online or offline. And if you're using something that dynamically swaps out class names, for example, so you might add a class to a div that then makes the background green if they're online, red if they're offline, and so forth. So this is essentially doing that, but just printing out the words online or offline. We also have the click event here, toggle status. So if we want to change the status, this will then invert the expression. So you can see here, you can ignore this top line for now. So what we're basically doing is creating a new object here with a property called online. And all we're doing is using the not operator. So we're inverting whether the user is online or offline. So what we can do is pass this particular piece of information up because the toggle status is being used as a callback. So here we have the this.status change, which if we go back slightly, not that way. Yeah, there we go. So we're expecting status change to be an output. So this is how we get informed from the child component, and we're basically just ping an event up from the child to the parent. So here is where we'd have the callback when something changes and we get that new piece of information. So this dollar event would correspond across to there we go. This.status change, the dollar event would correspond to this object here. So this is how we emit a change from a child component. So we're pretty much at the end. Hopefully this has been good for thinking about how to architect an app before you get started and how you think about creating nicer functions, but also creating nicer components with a well-defined API. So I've put a couple of bullet points here. Stateful components generally own a stateless component. So you could have multiple stateless components living inside a stateful one. The stateful one basically delegates to the stateless. So you can see, based on my code, I wasn't doing any bindings or anything, any click events, for example, inside my stateful. I was delegating these pieces of logic down into smaller components. And this makes testing and things like this much easier. What's also good with Angular is thinking about immutable operations. So the way that we essentially do change detection and the input bindings are basically faster if you use immutable operations. We can use a different change detection strategy in Angular. If you're interested and don't know about the change detection strategies, you can ping me on Twitter and just ask the question, and I will send you the link. So there's obviously tons and tons of stuff in Angular. This is basically just a brief on the component side. We also have something called NGRX Store, which Rob Warmold, who's part of the Angular team, he basically works on it with some other collaborators. But it's basically Redux, but RxJS driven. So it's using observables, these kind of things, for a Redux implementation in Angular. I was almost said Angular 2 then, in Angular. This is a really important and nicety of Angular is the ahead of time compilation. So this makes the payload size of an Angular app extremely small. So if you download an Hello World, an Angular boilerplate, you'll be looking at sort of 2 megabytes, I think, of like local development code. If you build out your application, let's just say we did a small to-do list, for example, and we use this ahead of time compilation, instead of the size of Angular being 2 megabytes, I think the smallest Hello World is around 25 kilobytes. So it can basically remove most of itself that it doesn't need, and it will pre-compile your templates into virtual machine friendly code. So this is like, instead of creating like for loops, for example, it will print them out in a VM friendly way. So it's optimized for like maximum speed. So it's not just payload size, but it's also the speed of the actual rendering. What's also nice is we can bootstrap in a web worker. So this story is kind of being worked on at the moment, and server side is being worked on at the moment. It's just moved into, it started as a community project and it's just moved into Angular's actual core. So there's lots of good things to come on the web worker side, which will essentially allow us to bootstrap. Well, it does allow us. It needs some further things, I think, in a web worker, so we can leave the UI as a completely just rendering only. So you could do heavy data processing in a web worker, which is a separate processing core in the browser, So this actually gives us a performance boost because we're just using the UI thread to simply render rather than doing perhaps a huge JavaScript iteration or a calculation, which we've likely all infinitely looped ourselves at some point or something like this. So it basically delegates that to a different thread. So yeah, that was all of it from me. Hopefully that was quite good. If you've got any questions, feel free to reach out on Twitter and I will be happy to answer your questions.
All right. Thanks, Todd. It was awesome. All right. You want to stop sharing your screen and turn your video back on? We do have a few questions here. Cool. We can go through these quick. All right. So Jack asked, so you essentially set up your callback functions in your parent component, i.e. the chat component in this example. Is this to mainly keep your functions centralized, or is there another reason to do this?
Are these in the thing that I can see, or are they in a different thread?
There's a Q&A thing. I don't know if everyone can see that.
Yeah, there's a button. That might help if I press it.
Yeah.
Give me a second. So you essentially set up your callback functions in the parent component, i.e. the chat component in this example. Yeah, so hopefully you can, I'll just move that there just in case. So the idea is I try and explain it in a fun way. Let's just assume I had a tennis ball, for example, and I'm the controller of the tennis ball. So I got to throw the tennis ball, and somebody's going to hit it back to me, and it's going to hit me in the face when it gets back. So that point where it hits me in the face is my callback. So something has then come back and told me. So that's the idea. And if you keep your components like a stateful component, sorry, I'm just pulling this wire, pulling it out of my ear. So if you keep your components like focused, like they shouldn't typically have too many functions because you can then break it down into another layer. So if your callbacks rely on something like a get request or a put request or a post request, so let's just keep it simple and say it's a to-do list. My to-do list callbacks, when I edit a to-do or delete a to-do list, the callbacks for those would live in the parent because the parent is the communicator with the service. So it can then throw the tennis ball off to the server and then get the response back. So that's the idea, is that everything's controlled in one place. So yeah, it would keep them centralized in the particular component.
Yeah. Yeah, I would agree too. Like this is a pretty common pattern in React from what I've seen and used too. And I really like it. Yeah. Like it just allows you to kind of keep the knowledge of, whatever state you're kind of tracking in the parent component can all be in the parent. And you can handle
this.
All right. Done. So maybe not as much on this talk, but maybe Angular in general. Maz asked, what is the state of styling in Angular? In React, we're seeing an increase in the use of CSS modules and libraries like Style Component, which Max is actually going to speak later in the week. Is there some component style encapsulation like officially promoted by Angular?
So it's kind of an interesting one. If you've played around with, I expect most people have used Sass or at least played around with Sass or less or something like this. So to start with, you can use Sass or less with Angular, but it's the point of getting it into a component and then doing something useful with it. So essentially, oh, is that the question disappeared or just moved?
It moved. I think one was added.
Oh yeah, let me scroll up. I'm just looking at it while I speak. So let's assume that we've just got styles. It can be less Sass, CSS driven, whatever. Sass driven, not CSS driven. It's obvious. It can be compiled, but it's then what does Angular do at the point of compilation? So there's essentially 3 different things that we can do. We call this view encapsulation. So if you've used Shadow DOM or played around with Shadow DOM, it essentially embeds a DOM within a DOM. And the DOM that it embeds is completely new. So it doesn't inherit, like, let's say you had .a as background red, and then you had a div inside your shadow DOM with a as a class name, those would not communicate with each other. So the first one is no encapsulation. So let's say in React, you could say, I don't want to encapsulate this component. It's going to be sharing its styles globally. That's one option. We also have, I'll start with the native shadow DOM because it's easier to understand the emulated. So you can either trip a switch and just say, I want to use native shadow DOM. If you're focusing on browsers that are very new, obviously the spec, not the specs changing, the support for the spec is changing. I'm not sure what the full status is on Shadow DOM. I think it might be pretty well supported at the moment. I don't think there's any browsers that are particularly lagging. You can say, I want to use completely native Shadow DOM. And in Angular's components, where it uses these property bindings, and it does this because it can bind to web components, Shadow DOM, this kind of thing. It will basically transform your styles and embed them in the Shadow DOM. So this gives you full encapsulation without using a library or anything like this. And then the emulated mode is where is currently the default. So this might change in a few years. So the emulated mode will basically rewrite. So you can, I think with React, you create, there's different ways of doing styles, but let's say we basically can use a SAS file, or you can just do styles and then write them all in a string. So Angular's compiler will basically rewrite them, the styles. Like let's say you did .hello as the class name, it would rewrite it to .hello, and then it would do square bracket and then a random hash key. So it creates an attribute on the element and it rewrites the styles for you. So it emulates the fact that they're encapsulated, and it does this uniquely per component. So it's not, your styles are never going to clash. So it keeps them very clean. And you've also got, I don't know how long it'll be till everyone's using native Shadow DOM, but when we're there, I'm sure they'll flick the switch to be Shadow DOM first over emulated, and then remove tons of code from the compiler.
Nice. All right. I'm actually going to skip the next one. We'll come back to it if we still have time. So Chris asked, can components send global events same as root scope, broadcast, and Angular 1, for example? How would you communicate to all your components that authentication has expired?
Yeah, so there's no root scope, emit, or broadcast in Angular 2 onwards. So in Angular 1, we basically had this idea of scopes, and the encapsulation would be done via scopes, not styles, but data and stuff like this. So you could create an isolate scope, and then you could basically use the root scope emit to then ping an event, either up one component or whatever is listening to it. So this was the pub sub way of getting around an Angular 1 app. In Angular 2 and onwards, the dependency injection is much, much nicer. It's observable based. So you've basically got RxJS baked into the core, and you can just dependency inject and subscribe to the state changes. So let's say I had an authentication service. I would set up some kind of subject or behavior that's can, like, what's it called? Angular Fire 2. If you check out the source code to this, you can basically subscribe to the auth state. So you can create your own subject and emit these changes if you're not using Firebase. And then in multiple components, probably stateful components, you would inject that service. So say our full email client, it injects the auth state here, here, and here. For example, you would then listen. You can basically just subscribe to the changes. So if the auth state changes, there's so much more you can do as well with like routing. So you can create a routing guard, and if your auth state changes, it will just redirect you to somewhere else if you try and navigate throughout the app. So yeah, there's no root scope, broadcast, and emit. They were okay if you kind of needed to dig yourself out of a hole. But in Angular 1, there is the doc component API, and it makes this architecture decisions a lot easier. which is pretty new. I think it was in the last year and 3 months the component API has been there.
Nice. All right. So the next question was anonymous, actually.
That's
What
the
is
name.
your debug workflow tools if the Angular is compiled, compressed, and delivered locally?
Does it mean browser, do you think, as clients? Or
Yeah, that's maybe my question here is like, what does he mean, like compiled and compressed? That would be more production, right? Like
yeah.
you
Delivered locally.
yeah. I would assume, like, I guess just maybe talk about like what kind of debugging tools you're using.
Debugging workflows.
Yeah.
So I mentioned the ahead of time, which we call AOT. The AOT compiler, which is the ahead of time compiler, basically outputs compiled code. So what I was showing with like import this from here and at component is not what is delivered to the client. So it's the AO, you can deliver it to the client but you want to compile the JavaScript at least, the TypeScript to JavaScript at least. However, you can take an extra step, which is the AOT. So what I tend to do, like for debugging workflow, you can look at the compiled output for the AOT stuff. So, excuse me, hiccups. So you can look at the source code in GitHub for Angular. You say, okay, I've got this weird bug, so I'm going to look at the function that is causing the bug, and you could look at the compiled output and then match it against the source code to see, or try and see where something's coming from. There's, I think I'm not sure how you pronounce it, Augury, one of the two, Augury, I think it's spelled, which is a Chrome extension for debugging Angular apps, which is useful for checking out. I think that's pretty much the thing covered. And TypeScript is the biggest debugging workflow tool that you can use. So I was really against TypeScript because I didn't know it. And then I started using TypeScript. I was like, how have I ever not used TypeScript? So, and me and my friend who were kind of against TypeScript because we didn't know it. We're just like every week we're like, I can't believe we didn't like TypeScript. So it's kind of grown. But once TypeScript clicks, it's superb, and it's basically like a spell check. Like the amount of times you spell something wrong or a property name wrong, for example, or just an import or a string or a type, you go back to the browser and you recompile the whole lot, and then you're like, I forgot to spell that right. So it basically just underlines the whole thing in red. It's like, this does not even exist. So
Right.
you're like, oh yeah. So TypeScript's probably the number one.
Definitely. All right. We'll take this one as the last question. And I'm kind of curious too, because I've been playing with next.js. Have you seen that?
I went on the website, but I didn't look any further in terms of using it.
So one of the, like, their two big things are, one, that they do server-side rendering. The other is that they have web worker built in that will do like prefetch data for like links that are on the page that go to the same app. And so it'll grab that data ahead of time so that when the page loads up, it's got it in memory and it loads. So anyway, that's one of the, I really like that web worker piece that they have going on. But Ryan asked, can you go more into what Angular people plan to do with web workers? Building those into the framework could be really powerful.
Yes, I think the web worker support started off as a Google intern. I think this is a story, that they were asked to basically come up with some kind of web worker implementation. And then they got it working and realized the benefits of doing so, probably similar to Next. I'm going to flick across to the docs real quick because there's the API reference docs. API reference. So the API reference is actually really nice. If I type web workers, there we go. I can't share this anywhere. If you go on angular.io and then click on docs, on the left-hand sidebar, it says API reference. Then you can type into a search box. I don't know if I can, I won't bother sharing the screen. So essentially you can type in filter the whole API reference. If you type in web worker or platform web worker, you can basically see what we got 6, 12, 18 different APIs. And then they've got the bootstrapping web worker dynamic for local dev. If you click on one of them, yeah, they're still experimental. So most of these, if not all of them, I think are fully experimental APIs. So these may be subject to change, but you can go ahead and use them now. What you will essentially need to do is bootstrap your application in a web worker rather than in the DOM as such. And you basically use the message bus, which you'll see message bus. Yeah, there we go. Message bus is a low-level API used to communicate between the UI and the background. So, excuse me. What's the other one? No. There we go. It doesn't have any documentation. This stuff's kind of raw at the moment. So, but yeah, you can still use it, and there are examples online of how to bootstrap in a web worker. But it's until basically because it's experimental, they can change it or deprecate it or change it in any versions. Like, well, I think the new strategy for versioning is like one ahead. So if they deprecate something, it'll be removed in the next major release. So anything that's experimental is probably smart not to go too crazy on until it says stable. And all of the API docs will have stable, experimental, etc. in the top.
Awesome. All right. Well, thank you, Todd. We have to get to the next session. I did put a link in the sidebar, and if you're not in the Slack chat, let me know because the links are also in there. You should have them in your email. And we'll be listening to Lynn Clark talk about WebAssembly with her cartoons, which I'm super excited about. And again, you can see Todd's name on the picture there. His Twitter handle is exactly the same. So.
I didn't even notice that until now. So
yeah, nice. All right, guys. See you in the next one.
Thank you.
This video has been a Space Dojo production. You can click the Learn More button to find out more about us at spacedojo.com. Or you can click the subscribe button to get notified about new videos we put out each week. Thanks for watching.